Okay, we're looking at page 149, problem number 12. A conical tank with vertex down is 10 feet across the top and 12 feet deep. So here we have a picture of our conical tank, our cone, and we see I drew it so that it's 10 feet across the top. That's 5 and 5. Okay, this 5 represents the radius of the top, the circular top, and 12 feet deep. Okay, that yellow line starting from here down to here, that's 12 feet deep. All right. Now, let's suppose that let's suppose we have water flowing into the tank. Water's flowing into the tank at the rate of 10 cubic feet per minute. So that's telling us that the volume is changing, or dV dt is equal to 10. Now we want to find the change of the depth of the water. All right. So here's the water. You see the water I drew with sort of blue stripes, and it's the water whose volume is changing. Now here's the depth of the water, and here's the radius of the water, and this water keeps increasing, this level keeps going up. So we want to know the rate of change of the depth of the water. Well, that's h. H is the height of the water, so we want to know what dh dt is. What is dh dt? dh dt is equal to question mark. The instant it is 8 feet deep. Okay, when h equal 8. Okay, because when you think about it, if water is flowing in at a constant rate, then initially, because the cone is sort of small at the bottom, initially the height of the water is going to increase quickly. And then as the water reaches the sort of the fatter part of the cone, or the wider part of the cone, the height of the water will slow down. So we want to find dh dt when h is equal to 8, sort of close to the top. Alright, we need a formula that relates our variables, that relates v and h. Alright, so we're going to use the volume of a cone. And here's the formula for the volume of a cone. V is equal to 1/3 pi r squared h. Alright, well, what about this variable r? Well, we have some more information that enables us to eliminate r. We have to use all the information given to us, and that information is that the width of the tank is at the top is 10 and the height is 12. We haven't used that yet. And we're going to use that in order to get an equation that relates r and h. Well, notice we have a triangle here down the middle of the cone. It's a right triangle. Is the right angle. And here's another right triangle that's in the water, that's sort of contained in that bigger right triangle. Let's take that picture out of the cone, those triangles. So here's the triangle that's going down the middle of our tank, and here's the lower triangle that represents the water. Alright, the measurements of this triangle are 5, and let's say this leg of the right triangle is 12. The shaded triangle, which represents the water, has lengths r, and the other side is h. So here we have similar triangles, and similar triangles give us an equation, a proportion, which is 5:12 as r is to h. Cross multiply, and we have 5h is equal to 12r. Or if we divide both sides by 12, we have, let me scroll a little bit. Okay, divide both sides by 12, and we have r is equal to 5h over 12. And that's the equation that we're going to use to eliminate r from this equation. Alright, so let's do that. Let's rewrite our volume equation and substitute 5h over 12 for r. Okay, let's square this quantity. All right, in the numerator we have 25h squared. And we have 12 squared, or 144, in the denominator. All right, let's rewrite. This is all a constant. 25 pi over 144 times 1/3 in front there. That's just a constant. And we'll just keep that in front for now. Okay, we've eliminated r. Now we're ready to differentiate our formula for volume. And so we have dV dt is equal to 1/3 25 pi. All right, and we always differentiate with respect to t in these related rate problems, because all our variables are changing with respect to time. So that's why when we differentiate h cubed, we bring down the 3, decrease the exponent to 2, and then since h changes with time, we multiply by dh dt. Okay, all right, now remember we want to figure out what dh dt is when h is equal to 8. That was the original problem. And dv dt is constantly 10. So let's just sub h equal to 8, and then we'll pretty much be done. We'll be able to solve for dh dt at that point. All right, so here we have 10 is equal to 1/3. Well, notice that this 1/3, this 3 in the denominator cancels with this 3 in the numerator. So I'm going to erase this 1/3 over here. Okay. Okay, so we have 10 is equal to 25 pi over 144. And here we have 8 squared dh dt. All right, 8 squared, that's 64. Replace it with 64. And let's divide by 16. 16 into 64 is 4 times. And it goes 9 times. We're dividing by 16 into 144. All right, simplify, rewrite. We have 10 is equal to 4 times 25, 100 pi over 9 dh dt. And finally, we can solve for dh dt by multiplying by the reciprocal of this fraction. So we'll multiply both sides by 9 over 100 pi on both sides of our equation. Here too, 9 over 100 pi. We're just multiplying by that factor. All right, let me scroll again. And so we got, in the numerator here we have 90. That's that 10 times 9, 90 pi over 100 is equal to dh dt. Divide top and bottom by 10, and we have 9 pi over 10 is equal to dh dt. H is a linear measurement, so our units here are, let's see what our original units were. I think they were feet and minutes, or is that right? Feet and minutes? Feet and minutes, yes. So our units are feet per minute. Okay.